Hello everyone, I'm Poonam Sharma, your science teacher. Welcome you all again another session of acid, bases and salt chapter. So in previous classes, I have discussed about acids, their properties and how do they react with the different substances, types of acids, test of hydrogen gas. We talked about reactivity series, and then we have discussed about bases, their properties, physical property, chemical property. So these topics I have already covered in previous classes. Now today I'll start with neutralization reaction. Although in previous class I've already started with this topic, I've given you a brief introduction of neutralization reaction. So what is neutralization reaction? If you remember, I have started this topic earlier also. So when acid and base, when they combine together, they react together, they form salt and water. So this kind of reaction is known as neutralization reaction. And when acid and bases react with metal oxides, they also result in the formation of salt and water. So those reactions are also kind of neutralization reactions. And here are a few examples of neutralization reaction. Look at these examples. See, when sodium chloride and water are formed, how they are formed? When hydrochloric acid and sodium hydroxide. So this is acid and this is base. So when they both react with each other, it results in the formation of salt, which is sodium chloride and water. Another example of such kind of neutralization reaction is when hydrochloric acid reacts with calcium hydroxide, which is a base. It results in the formation of calcium chloride, which is salt, and water is formed. So these reactions in which salt and water are produced as byproducts, we call them neutralization reactions. And reaction of acid and bases with metal oxides are also the examples of such kind of neutralization reactions. So these we have already discussed in previous class. And how can we show a neutralization reaction? So as I told you, in acids they have hydrogen ions and bases have hydroxide ions. So when hydrogen ion and hydroxide ions, they combine with each other, it results in the formation of water. So we can represent a neutralization reaction by this equation as well. These are the examples. Now look at this example. When sodium hydroxide, which is a base, sodium hydroxide, which is a base, reacts with hydrochloric acid. So what it forms? It forms sodium chloride and water. And this sodium hydroxide breaks into sodium ion and hydroxide ion. And this hydrochloric acid breaks into chlorine and plus H plus ions, which is not written here, I am just writing here. So H plus ions. This can also come here. So if sodium hydroxide breaks, it results in the formation of hydroxide ion, as you can see here, and sodium is there, okay? And if you are talking about acid, which is hydrochloric acid, it breaks into or it dissociates into hydrogen ion and chloride ions. And this hydrogen and hydroxide, so they both combine together, they form water. And this Na and Cl, they combine together to form salt, which is NaCl, sodium chloride. So this is how a neutralization reaction takes place. There are certain applications of neutralization reaction in our daily life. As I told you earlier also, I have discussed this point with you in previous class. So sometime after overeating or after eating spicy food, we feel indigestion, and or sometimes we feel acidity in the stomach. So to neutralize the effect of that acid, we'll take Eno or some another anti-acid tablet so that it neutralizes the effect of the acid which is produced in our stomach. In stomach, HCl is already produced. But if its concentration is increased, so it leads to acidity. To overcome with this acidity, we'll take some base which available in the market in the form of antacids, in the form of Eno. And second is neutralization reaction. Example is sometimes the soil on which farmers are growing their crops, sometimes it is too acidic or basic in nature. So in both the cases, crops will not grow. In that case also, farmers add acid or base accordingly. If soil is too acidic, they'll add some base, slate lime. If the soil is too basic, they'll add some acid in the form of manures. So to neutralize the effect of the acid to make it neutral, so that crops can grow easily. And these are the applications of neutralization reaction. Apart from this, when the stings of bees, sometimes bee stings and it contains formic acid, and we feel irritation in our stomach, on our skin, wherever this bees sting. So we feel irritation, some red spot appears, and we start scratching the skin. So in that case, we'll apply some base. Sometimes we start applying metal, because when metal reacts with acid, it shows this reaction. Or we'll use some calamine solution, that's a base, which neutralizes the effect of the acid. So these are applications of neutralization reaction in our daily life. Then dilution of acid and base. Again, there is one term, this dilution, which I have already discussed with you in previous session. Dilution is the addition of water in a acid or a base. So if we are adding water in acid or base, so it affects the concentration of hydrogen and hydroxide ion. So and the concentration of these ions, whether they are hydrogen or the hydroxide ions, they decreases if we are mixing water into it. So if we mix water into acid or base, it reduces the concentration of hydrogen and hydroxide ions, and this process is known as dilution. When we are performing this dilution, it's an exothermic process, whether it is a case of acid or base. In both the cases, it is an exothermic reaction, which means there is an evolution of heat. Heat is evolved. So this dilution of acid and base reaction is always exothermic. That's why it is always advised that add acid into water or base into water. Don't add water into them. If you need to add water, so take a test tube or a beaker, and in this take water, and then you can acid or water or base, whatever you want to add into it. Because if we are adding water, so it releases lots of heat from the acid, and which results in severe or dangerous accidents. So to avoid those accidents, we always prefer to add acid, because whatever heat is released, that is absorbed by this water. So it prevents us from the severe accidents. It's a 2-mark question. And now, what type of question can come? How is the concentration of hydronium ions affected when a solution of acid is diluted? Hydronium ions or hydrogen ions, they both are present in acids. And if we add water and we are diluting it, the concentration of hydronium ions or hydrogen ions, it decreases. Now, on what basis the strength of acid and base depends? If more concentration of hydrogen ions are present, so we call it strong acid. If complete dissociation of hydrogen ions, and if partial, then we call it weak acids. We call them weak acids. And if the dissociation of hydroxide ions is complete, they are completely dissociated into hydroxide ions, so we call them strong bases. And if they are not completely dissociated into hydroxide ions, we call them weak bases. So the strength of acid and base depend on the dissociation of ions present in them, whether it is hydrogen ion or hydroxide ion. Now here is a scale which was discovered by Sorensen. Sorensen, he discovered a pH scale. This pH scale detects or tell us that which substance is acidic in nature, or which one is basic in nature, or which one is neutral in nature. And it is based on the pH value of the substance, whether it is an acid, base or neutral one. So here pH refers to, here pH means the presence of hydrogen ions or hydronium ions. Hydronium ions, or we can write presence of hydrogen or hydronium ions. So here, how can we define pH? pH is the presence of hydrogen ions, or the concentration of hydrogen ions in a given sample is known as its pH, and it is represented by minus log base 10 H plus. And this P stands for potence, means power. It means power. So the power of a substance or a solution which contains hydrogen or the hydronium ions. So if more hydrogen ions are there, then less pH is shown on the pH scale. So it means if less pH, it is very acidic. If more pH, it is basic in nature. And if it comes at the scale of 7, it is neutral. And the marking on pH scale is from 0 to 14. And they'll show different colors, which was discovered by Sorensen. So this is how we detect whether the substance is more acidic or less acidic, or we can say that whether it is strong acid, weak acid, or strong base, weak base, or whether a substance is neutral in nature. When we perform any experiment, whatever color we get after performing it, so that shows that what is the nature of that particular substance. For example, if we are taking water on a pH paper, so if its color shows this one, so we can see the color of the pH paper and match that color with the pH scale, and this shows that it is neutral in nature. And if you take HCl, hydrochloric acid, then drop this HCl on a pH paper, and if you observe the color, its color comes red. So just match the color with the pH scale, and then you come to know how much acidic is it. It is in nature. And if it is dilute one, so obviously the pH value increases. So it means it has less number of hydrogen ions after adding water into it. So you can take concentrated and dilute HCl and then see the pH value of both the solutions. And dilute means we have already added water into it. So if we are adding water into this, so obviously its acidic nature decreases due to the decrease in the hydrogen ions. And if acidic nature decreases, it means its pH value increases. So more pH value, it means less acidic in nature. And if we are talking about basic solutions, solutions which have pH value more than 7, so they are more basic in nature. So it means if we are moving toward this, so acidic nature decreases. And if we are moving toward this, basic nature increases. So this is how we can detect the nature of a given sample. And universal indicator, as I told you, we call litmus a universal indicator. This litmus paper is obtained from lichen. Apart from litmus paper, we have other indicators like phenolphthalein, methyl orange. These are neutral in nature, and when we react acid and bases with these universal indicators, they'll give different colors. So here are few examples of certain materials which we are using on daily basis and their pH value also. If we are talking about battery acid, its pH is 1. It means it is very acidic in nature. Gastric acid, 2. Hydrochloric acid, 3. Soda, 4. It also contains acid, carbonic acid. Acid rain, 5. Then black coffee, 6. Then saliva, it's 7. Pure water is 7. And then these are the basic in nature. Then drain cleaner, bleach, soapy water, ammonia, milk of magnesia, baking soda, seawater. So all these are bases or alkalis. And if you remember, I have discussed alkalis with you in previous class. Bases which dissolve in water are known as alkali. So as you can see, by performing experiment or with the litmus paper, we can see that we will get different colors with different type of the solutions which we have in front of us. And when we match this color, so we'll get an idea the nature of acid, bases or neutral in the given solution. Now, what is the importance of pH in our daily life? So pH value plays a vital role in our life. So first of all, if we are talking about digestive system, as I told you, dilute hydrochloric acid, it already present in our stomach, which helps in the digestion of food. It is present in the stomach, which helps to break the proteins into peptones. Whatever protein we are taking, so this HCl helps to break that protein into simpler form. But to certain extent, if the concentration of HCl increases in the stomach, and how it will increase? By eating spicy food or by overeating, so it starts releases HCl. If the concentration of HCl is more, it causes acidity or we feel indigestion. So in that case, we need some strong base. That's magnesium hydroxide, which is antacid or milk of magnesia, or you can take baking soda, or you are drinking Eno. So they are strong bases. So when we take these bases, they neutralizes the effect of acids which are produced in our stomach. And this is an also example of neutralization reaction. So pH plays a vital role. If the pH of our digestive system, if the pH in our body fluctuates, so it causes it makes us or feel us uncomfortable. So in that case, we'll take some strong base so that it neutralizes the effect of each other. Second is tooth decay caused by acids. When we eat some sugary substance, So due to the those sugary substances, it starts secreting. It converting into acids by the action of bacteria which are already present in our mouth. So if we are not rinsing our mouth after eating food, in that case also bacteria start converting that food material into acidic form, which results in cavity. And then in that case the pH of the mouth falls below 5.5, and it results in the decaying of our tooth. Then in that case the excess of acid should be removed. And how can we remove it? By using good quality of toothpaste. Toothpaste contains strong base, and this toothpaste neutralizes the effect of the acid which was created by bacteria which were already present in our mouth. So that's why it is always advised that after eating food or after every meal, rinse your mouth properly. Because if some food particles stuck between the teeth, the bacteria start attacking on them and starts converting those food material or sugary substance into acid. Now third is soil of pH and plant growth. As I told you earlier when I was discussing neutralization reaction also, soil has some tendency to grow crops on it. If soil is too acidic or too basic in nature, in both the cases crops will not grow. So to overcome this situation, where farmers add acid or basic substance according to the need of the soil. If the soil is too acidic, in that case, the farmer adds slake lime so that it neutralizes the effect of acid. And if the soil is too basic in nature, so they'll add manures which contain organic matter. Uric acid is present in it also. So it neutralizes the effect of paste and it makes the soil neutral so that it is easy for the farmers to grow the crop. And crops can easily grow. So these are the applications or the importance of pH in our daily life. That's why we are saying pH plays a very important role. Then apart from this, pH of the skin. See, some animals have this self-defense mechanism. As in case of bees, when they sting, when you go near to them, they sting, and in their sting, one acid is present, which is formic acid. So in their defense, they inject this formic acid into your body, into person body who goes nearby to them, and due to the injection of this formic acid in our skin, it causes irritation. And being acidic in nature, will need some base to neutralize its effect. So in that case, we'll use calamine solution, which is a strong base to neutralize the effect of this formic acid. Then these are the examples or applications of pH in our daily life. Now, what kind of question can come in exam, and whatever applications or the importance of pH and the neutralization reactions I have discussed with you, these all are extremely important questions. Generally, they come in 2 marks. So, first question is, mention the pH range within which our body works. Explain how antacids give relief from acid. Write the name of one such antacid. Our stomach has pH equal to 2, which is already acidic due to the presence of hydrochloric acid. It is already acidic in nature, but till this pH we can adjust. Will not feel uncomfortable. But if it decreases from 2 to 1, so then we feel uncomfortable. In that case, we use antacid which neutralize the effect of the acids in our body and will feel relief from that acidity. And the example of such kind of antacid is sodium hydrogen carbonate, which is a strong base. Now, second question is, fresh milk has a pH of 6. How does the pH will change as it turns to curd? Explain your answer. Have you ever tasted curd? Just see the difference in the taste of curd and milk. Curd is quite sour in taste. It means it has some acidic property. So pH of the milk decreases when it converts from milk to curd, and due to the presence of lactic acid into it. So when we convert milk into curd, so the pH of milk decreases, which results in the formation of curd due to the presence of this lactic acid. Now next question is, a milkman adds a very small amount of baking soda to fresh milk. Why does this milk take a longer time to set as curd? And next is, mention the nature of toothpaste. How do they prevent tooth decay? Now first is, a milkman adds a very small amount of baking soda. Generally in shops, when they are making curd from milk, they'll add baking soda. Although we are not using in our home, but we can see the difference in the curd which we get from the market and in our home. That curd is quite thicker. This is due to the addition of baking soda into curd. And why they are adding and why it will take longer time to set. Because the conversion of milk to curd, it takes place under the action of bacteria present in them. So those bacteria plays a vital role in converting the milk into curd. But if we add baking soda is a base, and although the pH of milk is already 6, and if we are adding baking soda into it, its pH is increases. So the bacteria cannot act on that high pH. So it will take time to convert it. So that fermentation of this process will take place very slowly. That's the reason it will take more time to convert into curd. Next is, mention the nature of toothpaste. As I told you, if we are eating sugary substances, or we are not rinsing our mouths after meal, so those food particles which stuck in our teeth, bacteria which are present in our mouth, they start attacking on them and converting into acid form. So in that case, we need a toothpaste which is quite basic in nature, so that it neutralizes the effect of acid which was formed by bacteria. So that's why toothpaste are basic in nature, so that they will nullify the effect of this acid. Then we have salts. Salts are ionic compound. Why we call them ionic compound? Because they are formed after the neutralization reaction of acid and base. We have already discussed this point. When the reaction takes place between acid and base, it results in the formation of salt. So it has both positive and negative ions. So that's why we call them ionic compounds, because they have both positive as well as negative. Then they are electrically neutral. I'll just take one example. Electrically neutral. NaCl. NaCl is Na and Cl. So I'll write again. NaCl, positive and negative. So it means when they dissociates, when NaCl dissociates, it dissociates into Na positive and Cl negative. So due to the presence of both the charges in them, it is electrically neutral in nature. And there are number of salts, but sodium chloride is the most among that generally we are using in our home. It's a very common salt which we are using, and we call it table salt also. So it enhances the effect of food, taste of food. Now, what are the characteristics of salt? When you touch salt, so you'll see they are they have small minute crystals which are shiny in nature. See salt today, take some salt and look at the structure of a salt. It's crystalline. It means small crystal, geometrical shapes. Some geometrical shapes are there like this. That's why they are crystalline solids. And they may be transparent or opaque. If you take a rock of a salt, so it is transparent. So they may be transparent or opaque. And most of the salts are soluble in water. When you dissolve them, they can easily dissolve in the water. And salts conduct electricity due to the presence of ions in them. As I told you, they contain positive and negative both the ions, and due to the presence of these ions, salt can easily conduct electricity. Now, salt may be salty, sour, sweet, bitter. If we are adding flavors into it, so they'll give different taste. And neutral salts, which have pH 7, they are odorless. Salts can be colorless or colored depending upon their the location where they are found. So the pink salt we have, Himalayan salt we have. So we have different kind of salt like copper sulfate. So it is blue in color. So we have different colors of the salt. Now here we are talking about family of salt. So we have different type of the salts. If the salt have more acidic property or more basic property, depending upon that we have different types of salt. As we are saying, salt is a combination of both acids and base. Now, sodium chloride, it belongs to chloride family due to the presence of this chlorine in it. So examples of such kind of chlorine is calcium chloride, zinc chloride. If chlorine is added to metals, it becomes chloride salt. Then we have neutral, acidic and basic salt. If the concentration of acid and base both are equal and the pH of salt is 7, so we call it neutral salt. And examples of such kind of salt are sodium chloride, sodium sulfate, potassium chloride. It means acid and base, they both are present in same ratio, in same proportion. So these kind of salts are known as neutral salts, which we are using in our house on daily basis. And look at the examples of such kind of salts. As you can see here, the percentage or the ratio of acid and base are equal. And these are the reactions between them. Sodium hydroxide, hydrochloric acid from sodium chloride and water. Then sodium hydroxide, sulfuric acid, it forms sodium sulfate and water. Then potassium hydroxide or hydrochloric acid, it forms potassium chloride and water. So these salts are neutral in nature. And they are a combination of acids, these are acids, all are acids, and base. So again, it's an example of a neutralization reaction. Now, acidic salts. Acidic salts are those salts in which the ratio of acid is more and their pH is lower than 7. So these kind of salts are known as acidic salts. An example of such kind of salts are ammonium sulfate, ammonium chloride. So it means in this they have strong acid and weak base. So this strong acid overcome the property of weak base and it shows its effect. So that's why this salt become acidic in nature. And examples of such kind of acidic salts are ammonium chloride, ammonium sulfate. As you can see again, when acid and base acid and base react, ammonium chloride is formed and water, reaction remains the same. Always salt is formed, water is formed after combination of acid and base. So it depends whether it is a strong acid or weak acid, or strong base or a weak base. So whatever strong substance is present, that shows its effect. So on the basis of that, salt is produced. If we are taking strong acid, then acidic salt is produced. If we are taking strong base, then basic salt is produced. Then we have basic salt. So basic salts are formed when the reaction takes place between weak acid and strong base. And examples of such kind is sodium carbonate and sodium acetate. So these are the examples of basic salt. Here we have taken strong base and weak acid. So as you can see here, again carbonic acid is a weak acid and sodium hydroxide is a strong base, which results in the formation of sodium carbonate and water. So here another example of such kind of basic salt is sodium acetate. Like acetic acid and sodium hydroxide, when they combine together, they form sodium acetate and water. So here in this we have seen that we are taking strong base and weak acid. So these are the examples of basic salts. So I hope till here it is clear to everyone. Different type of salts, neutral salts, acidic salts and basic salts. So I'll just end my class here. So we have discussed till types of salt, neutral, acidic and basic. So these are the examples which I have already discussed with you. And what is the reason behind it when we are combining acid and base together? So it results in the formation of different type of salt. Cause of formation of acidic, basic and neutral salt, as I told you, if we are taking strong acid, it results in the formation of acidic salt. If we are taking strong base, it results in the formation of basic salt, and if both are equal, so we call it neutral salt. And the pH of acidic salt is less than 7 and the pH of basic salt is more than 7 and neutral salt is 7. So these are the examples. So neutral salt, acidic salt and basic salt, and it is their pH. Now I hope till here it is clear to everyone. Now if you have any doubt, you can ask. So as you can see, these are the different type of salt which I have already discussed with you. Now there are certain important chemical compounds. So till here we have discussed so there are certain important chemical compounds. Let's discuss those compounds. First is common salt. Which we are using on daily basis, that is also known as sodium chloride. Chemical name of common salt is sodium chloride, or we call it table salt. And how this is formed? This common salt is formed by when reaction takes place between sodium hydroxide and hydrochloric acid.